Hello guys, today I am going to discuss about one of the major topic of computer networks, that is TCP/IP addressing. Whenever we logged into internet, we must go through the IP addresses. This is IP addresses is nothing but a secret address which defines your device uniquely over the internet. So without delay, let's proceed and let's know what is this all about. Now in this slide you can see an internet according to the TCP/IP. This transmission control protocol and the internet protocol. This is a specially designed communicational model which has been used through the global internet system. So in the left side you can see the actual internet. That means every machine like A, B, C, D, E, F, G, these are the nodes or end machines which has been connected with the internet via 1, 2, 3, 4, 5 these small subnets or zones or routers, whatever you name it. And these routers are internally connected between these small red blocks numbered at 1, 2, 3, 4, 5, 6. So this is the major framework of internet systems throughout the globe. But when we comes in the IP and TCP/IP model, we can see the internet as a whole thing. So you can see that the total yellow block is the internet, which is giving information to A, B, C, D, E, F, G, any end user or end client machine. So ad hoc communication can be possible through the internet and end-to-end communication is possible. How is it possible? Let's go to the next slide and find it out. So here you can see the TCP/IP and the OSI model suite. So you can see that there are 7 different layers which has been mentioned, and these 7 layers, in the topmost sections you can see application, presentation and session layer. These 3 layers are merged together in terms of TCP/IP model. But when we are considering the OSI model, these 3 layers are separated. But in modern communication pattern, we use total 5 layers. Now you can see the application, presentation and session layer have multiple protocols like SMTP, FTP, Telnet, DNS, SMMP and TFTP. So SMTP stands for Standard Mail Transfer Protocol, FTP stands for File Transfer Protocol and so on. We will discuss about this protocol on a next video lecture. Now proceed to the transport layer. You can see TCP and UDP. So these are the protocols which has been used for the communication purpose. One is connection oriented and another is connectionless. We have to take another session for discussing these 2 protocols. Now in the network zone you can find different protocols, that IGMP and ICMP and ARP and RARP. So in the last 2 sections you can see data link layer and physical layer. Protocols defined by these underlying networks has been defined in a synchronous way, and we will discuss about this later. In the right section you can see the workability or the functionality of the layers. In the application, presentation and session layer you can see this is working for the message section. In the right, in the transport layer to network layer, you can see that this segment or user datagram. That means it has been segmentized in a different datagram format. What is the user defined datagram and network datagram? We will discuss it later. Now in the data link section we can see the frames, the concept of frames, and in the physical layer we can see the concept of bits. So we have already discussed about these things, what is the frame, what is the data bits and how we are transmitting these things. So for now we are skipping this part. Let's go to the next slide. So now what we are talking about this internet addressing. In general, IP, that is internet protocol address, has been defined in 2 sections, one IPv4 and one IPv6. IPv4 is made out of 4 bytes, that is 32 bits. That defines a host connections to a network. And IPv6 used 6 segments, that is 128 bit. We will discuss about IPv4 now. So in any IP address or internet address, we will have 2 parts. One will be the net ID, another will be the host ID. Note, it's very important, every IP address are unique. If it is not unique, there will be a problem in communication. So every time you have to check that the IP address is unique or not, or the system will do it for you. Next, the addresses space of IPv4 is 2 to the power 32. That means every IP in class 4 addressing will have 4 parts, and this 4 parts is consist of 8 bits. So there is total number of 2 to the power 32 bits. Now in this figure you can see the 4 different section of any IP address. So 128 stands as 1000000. Likewise 11 stands for some different binary value, 3 stands for different binary value, and 31 stands for different binary value. If you clearly convert these numbers into its corresponding binary form in an 8-bit section, you will find this. And in reverse, if you convert any 8-bit number into corresponding decimal form, you will find the decimal number. This is the way we are doing it. Now you can ask why we are doing it. See, we humans are lazy, so we need the system to work for us. It is impossible for anyone to remember this big number of a binary sequence, and for that we are converting that binary into decimal form. Still, it is not the end. We don't able to remember more than 5 or 6 different IP addresses. If it is 5 or 6, we may remember less. So now we will be converting that into its corresponding name form. That will be discussed in the DNS section. Now, for example, let's see, change the following IP address from binary notation to its dotted decimal notation. First, check the example marked as A. So it has been given 4 different binary values. So what will be the solution? We have to convert the binary value of each segment into its corresponding decimal form. And how we will do it? First, we have to consider the last bit from left to right order will be 2, the next will be 4, the next will be 8, next will be 16, and so on. So it's a power of 2. So by this way, we will put the values corresponding to its decimal value and we will add it. After addition, we will find the corresponding decimal value. So this is the way we are converting every segment, and thus for A we will be getting 129.11.11.239. This is the way we have to convert B, C and D, and we will get the result for B is 193.131.27.255, and for C some value and for D some other value. Let's see example number 2. Change the following IP addresses from the dotted decimal notation to its binary notation. Just you have to convert that corresponding decimal number to its binary form in a reverse order. So for A, if it has been given 111.56.45.78, so the corresponding binary conversion will be 011011111 001100 00101101 01001110, and this is the way we will be converting B, C and D. In example number 3, find the error, if any, in the following IP addresses. Now this example is very crucial and important. For A, we will be having 111.56.045.78. So can you guess the error? The error is you cannot start any IP addresses with 045. You cannot put 0 after the dot. Next, for B, the IP address is like that 221.34.7.8.20. No, it cannot be possible. You have to make only 4 blocks of IP address. This is class 4. So there is no such space where you can put 4 dots. Now in C, 75.45.301.14. It is also impossible because the IP ranges 2 to the power 8 bits. That is the highest number, that is 256. So last number you can put is 255. The series starts from 0 to 255. So 301 is not possible. Now in D, it's 111.00010.23.14.67. So here it is also not possible because you are converting binary and decimal both together in the same IP address. It is not possible. Either you have to type the decimal or you have to type the binary. Now we are going to discuss about the classful addressing. IP addresses, when started a few decades ago, used a concept of classes. This architecture is called as the classful addresses. This is nothing but the segmentation of the IP addresses so that we can have multiple IP addresses, blocks of IP addresses, where we are able to distinguish each and every segment of small networks and they should not interfere to each other. In the mid 1990s, a new architecture called classless IP addressing was introduced and will eventually supersede the original architecture. However, the part of internet is still using the classful addressing, but the migration is very fast. So now people are actually converting every system into classless IP addressing. So we won't go for the classless IP addressing in this discussion, but on the next discussion we will definitely discuss about the classless. Now we will be focusing the classful addressing. So now in the next slide we can see what are the address spaces has been occupied by the classful addressing. So in the address space we can see A has taken the 50% of space, B less than that, C very less than that, and D or E almost similar, and which are combining the space equivalent to C. So now in a mathematical way we can see how many addresses per class have. A has 2 to the power 31 because in a 32-bit address 2 to the power 31 bits are usable. That means the 50% of the space. B is using 2 to the power 30, that is 25%. C is using 12.5% and D and E is combiningly using 6.2% each, that is 12.5%, which I have just told you. In this diagram you can see what is actually happening. As I have told you earlier that there are two segments, one is the net ID, another is the host ID. So in the case of class A addressing, the net ID is only 1 byte, that means only 8 bit. So it is having only one block of address which is kept for the network and 3 bytes kept for the host. Class B, there are 2 net ID blocks and 2 host ID blocks. Class C is having 3 net ID blocks and 1 host ID blocks. Class D and Class E has been kept reserved for future use and multicast address as well as for the research purpose. Now in this block you can see how many byte is usable in a decimal notation. So for class A you can have 0 to 127 for first byte as a network ID, 128 to 191 if the segment is having of any IP address is in class B, 192 to 223 it is for class C. That is only usable for us if we are doing any classful IP addressing. So if you see any IP address is having an address like 193.200.201.1, so it will be there in class C because the class C network ID ranges start from 192 to 223. So this is a more clear diagram for you. The classes range of IP addresses or the internet addresses are like this. So the net ID and host ID is a starting point to the ending point. So class A having 0.0.0.0 starting from this address to 127.255.255.255. So this 255.255.255 is actually the end user's machine address. You can alter this, you can modify this according to your size of the network. So class A is having the biggest network where you can keep lots of machines together. Class B is equivalently less number of machines, and class C is having very small group of machines. Only 255 machines or 256 machines can be connected within the same group because 3 blocks of net ID has been blocked and only 1 block of host ID has been kept, and D and E both are kept undefined and for the research. So this is the segment of IP addresses which I have already discussed, and you can now again see how it has been converted into its decimal form. The binary has been taken and it has been converted to decimal form. Now for the network and host addresses. For the network and host addresses, you can see there are different block of networks are there. In the lowest most area you can see 124.0.0.0. In the lowest most area you can see this, because the host ID is nothing but the address which connects the system or the network with the global internet. R stands for the router. It is having a specific router IP address. So the host ID is actually responsible for connecting the router with the same network. Every network is having the host ID which controls the network, and it allows the network to connect through the global internet. So this is a two-level hierarchy of internet. So what is there? Every small segment of hosts that is there within the block of network is being connected with a particular network ID. The network ID is 141.14.0.0 and it's been connected with the R1, that is the responsible router, to the rest of the internet. So there are two segments. One segment which is the network address which connects the entire internet or the entire network with the router R1, and thus this R1 is taking care of transmission and receiving the data through the internet. Now this is the three-level hierarchy. You can see there are three different host addresses, and these host addresses are sharing the information with R1 to connect with the internet. The site address of this entire network is 141.14.0.0. So this is actually the third layer. So there are three different layers. R1 is one layer, site address is one layer, another small layers are 141.14.2.0, 141.14.7.0 and 141.14.22.0. So there are the three different layers or the levels of the hierarchy. Now we are going to the next thing, that is the masking. What is the masking? An address in the block has been called as mask when an AND operation is being used over the address in the beginning of the address. So the first segment is need to be masked with the AND operation, and thus is converted to the masking address. So now address without subnetting and subnetting, you can see any network ID and host ID is having two parts, but one address from the host address, the first mode block of the host address is called as the subnet ID. That means a network within the same network. And how to distinguish that? Just after the net ID ends, the immediate block of the IP address is been connected with the internet in a mode of subnet ID. So whatever the address is there, it is considered as the subnet ID. Now going back to the masking thing, whenever an IP address is having or gone through the AND operation like 141.14.2.21, so the masking address will be 255.255.0.0. That is, it is in class B IP addressing. So the network address will be 141.14.0.0. So what it does? It is filtering or it is converting the net IDs with the corresponding IP which is coming and setting the host IDs to 0 in this first block without subnetting. But when we are doing the subnetting thing, we are taking the net ID and the host ID for the same IP address 141.14.2.21. So 141.14, which is the net ID, is fixed, and 2 will be taken as subnet address, and then 21 is set to 0 to initialize the first block of the masking address. So from the host ID, that is 0, it start counting 1, 2, 3, 4 and so on for the new machines which will be connected with the same network. So this is all from my side. Hope you enjoy the entire presentation, and see you on the next slide and on the next video with more discussions about these leftover topics which I have kept today. Thank you for watching this video.